Good morning, class. So today we're going to be discussing about the inverse one-to-one functions involving parabola. Okay, here's our content. Okay, for the problem, Brielle, a builder, goes to a skate park. The park contains a ramp at ground level with a height of 4.5 meters and a base with a length of 6 meters, which has a parabolic curve of y equals 1 over 8 times x minus 6 squared, restricted at a domain. She plans to build another ramp right beside it, with the curve inverse to the original ramp. Bria sketches the graph of the two ramps. She then wants to mark the point at which the two ramps intersect, so that skaters can safely identify where to switch between the two ramps back and forth. What will be what will the height and the length of the base of Brielle's new ramp be? Determine the curve of the new ramp, sketch the graph of the two ramps, and find the point at which the two ramps intersect. Okay, for our analysis, we know that the given is the height and the length of the base of the ramp, which is 4.5 and 6 meters respectively. The curve of the ramp, which is y equals 1 over 8 times x minus 6 squared, restricted at a domain, and that the ramp is at ground level. Then, we were tasked to find the height and length of Brielle's new ramp, the curve of the new ramp that is inverse to the original ramp, the graph of the two ramps, and lastly, the point at which the two ramps intersect in the graph. But first, how did we derive that y equals 1 over 8 times x minus 6 squared is the curve? Well, generally, a parabola can be expressed as y equals a times x minus h squared plus k, where hk is the vertex of the parabola and a determines the wideness of the parabola. And x and y represent the horizontal and vertical points respectively. Given that the ramp is at ground level, assuming that ground level refers to the x-axis, k must be 0 because k determines the height of the vertex, and since we are at ground level, k must be 0. Since k equals 0, h must be the point where the base of the ramp ends, and since the base of the ramp is 6 meters, h must be 6. Now we have found out the values of h and k, which are h equals 6 and k equals 0. Therefore, the vertex is at 6, 0. Now, to solve for a, we know that the height of the ramp is 4.5 meters at the point 0, 4.5. Substituting the point 0, 4.5 to x and y, and the vertex 6, 0 to h and k, we can solve for a, where negative 6 squared is 36, divide both sides by 36, simplify, then you get 1 over 8 equals a. Now that is how we derived the function of the curve earlier. Now, for the graph, but why is it restricted at a domain? Well, the graph of a parabola is not a one-to-one function, so we must restrict to one side of a parabola. Since the vertex of our parabola is at 6, 0, we can restrict it to only the left side of the parabola, which is when x is less than or equal to 6. But we also restrict it until x equals 0 because that is where the height of the ramp reaches its maximum, which is 4.5. Therefore, the domain of the parabolic curve of the ramp must be restricted at 0 is less than or equal to x is less than or equal to 6 to ensure that it makes it a one-to-one function and that it illustrates the ramp. Then, for our graph, the blue curve here is the ramp of the original ramp, the graph of the original ramp, and the red is the curve of the Brielle's new ramp. So for our asymptotes, it's not applicable since we don't need any asymptotes in our graph. For the x-intercepts, it is where the two graphs touch the x-axis. To solve for the x-intercepts, we set y is equal to 0 and then solve for x. Then, for the y-intercepts, it's where the two graphs touch the y-axis. To solve for the y-intercepts, we set x is equal to 0, then solve for y. For the domain of the first graph, it is x is such that x is an element of all real numbers from 0 to 6, and the range is y, such that y is an element of all real numbers when y is from 0 to 4.5. Then, for the inverse of that, which is Briel's new ramp, the domain is x such that x is an element of all real numbers where x is from 0 to 4.5. Then the range is y such as y is an element of all real numbers where y is from 0 to 6. But the graph shows the two ramps overlapping. How can Brielle build the ramp when it overlaps the first ramp? So see here, they overlap. How can Brielle build a new ramp when it overlaps this old ramp? Well, because the graph only shows the view of the two ramps at an angle where it looks two-dimensional. Looking at it from a three-dimensional point of view, we can see that Brielle's new ramp does not overlap at the first ramp, but right beside it, as stated from the problem earlier. She plans to build another ramp right beside it. So here is where the graph shows the two ramps at an angle where they look two-dimensional from the point of view. And the sphere here shows where the two ramps intersect. And here is the graph of the two ramps at another angle. So we can see that it does not overlap, but they are only right beside each other. So now we must work out the problem. So going back to the analysis, we were tasked to find the following: the height, the length, the curve, the graph, and the point at which the two ramps intersect the graph. So to find first we must find the inverse of the original curve of the ramp, which is y equals 1 over 8 times x minus 6 squared. To solve for the inverse, we must swap x with y, then solve for y. So we swap x and y, then we multiply both sides by 8 to get rid of 1 over 8. Then we square both sides. Then we add positive 6 to both sides. Then we simplify square root of 8x, which is gonna be 2 square root of 2x plus 6. But there are two roots. We only need to get the negative root to match the inverse of our original graph. So the answer will be y equals negative 2 square root of 2x plus 6. That is the new curve of Brielle's ramp. Next, we find the height and length of the base of the new ramp. To find the height, we set x equals 0 to the new function because the maximum height of the ramp is where x equals 0. So 2 times 0 is 0, negative 2 times 0 is 0, plus 6 is 6. Therefore, y equals 6. And to find the length of the base, we set y equals 0 to the new function because the ramp is at ground level, assuming that ground level refers to the x-axis, which is when y equals 0. So when y equals 0, negative 2 square root of 2x plus 6, we add 2 square root of 2x to both sides, which cancels this. Then we divide both sides by 2. 6 divided by 2 is 3. Then we square both sides to get rid of this radical. So we get 2x equals 3 squared is 9. So we divide both sides by 2 to get x. Therefore, x equals 4.5. Therefore, the height of Brielle's new ramp is 6 meters and the length of the base of the new ramp is 4.5 meters. Now we check the graph of the two ramps because earlier the problem stated that Brielle sketches the graph. So we plot the line y equals x to check if the two graphs are reflecting to each other at this line, which is correct because they are inverses. Yep. Lastly, we check the graph of the two ramps to see where they both intersect. By looking at the graph, we can see that they intersect at the point 2, 2. They intersected here. For our conclusion, after working out the problem, we can conclude that Brielle's new ramp follows the parabolic curve of the function y equals negative 2 square root of 2x plus 6, and by setting by setting x and y to 0, we found that the height of the new ramp is 6 meters and the length of the base is 4.5 meters. After Brielle graphs the function of the two ramps, by looking at the graph, she sees that the point of intersection between the two ramps and the graph is at 2, 2. Yay! Thank you for listening.